All right. Thank you for showing up at this late hour. Really appreciate it. I'm Claudius Lee. I'm one of the product managers at Starburst, particularly focusing on our Lakehouse connectors. And this is Tom Natz. Introduce yourself for a second.
Director of Customer Solutions at Starburst. Been here about 3 years. Nice to meet everybody.
All right. So what we're going to talk about today is how you can use Trino and Delta Lake to build a lakehouse. And for those of you who saw Denny and TD's talk, you can sort of think of this as a deep dive into how the community is going to work together to build out these solutions. Oh, nice.
Thank you.
All right, so let's go over how we're going to go through this, that you can keep everything in your head. First of all, not everyone here likely knows what Trino is. I'm sure you all know what Delta Lake is, or we wouldn't be here. Any exceptions? Do we need a quick Delta Lake explanation? Okay, all right, we'll talk about Trino. Then we're going to talk about how it works with Delta Lake. And then we'll talk a little bit about how people are actually using this in the real world to solve problems. And then after we go a little bit into what is coming next and how we're going to build this out further, and then Tom is going to actually show you this in action so you don't have to just believe what I'm saying. All right, so what is Trino? Trino is a single point of access for all your data. And the way this works is you have a coordinator and a number of worker nodes. The largest number of worker nodes we have, do you know what that is? I think
like 1,200, I think.
1,200 or so? Yeah.
That was a Facebook.
Yeah, okay, yeah, so let me give you a little aside here. You'll see Hive down in the corner there, right? That was actually the original use case. When our developers originally built Trino, they were working at Facebook, and they have sort of Facebook scale data on Hive. And the issue was that on a good day, their analysts could run 6 queries. So Martine, Dane, David, and Eric got together. They built out Trino. It was called Presto at the time, and promptly crashed Facebook because they saturated the network links. And the interesting thing is the response was not to turn off the queries. It was to upgrade the network infrastructure. And there's 2 important things out of this. One is that often you can get more performance out of your data sources than you think you can, potentially. And 2, if there's value in that data, then you should pay for the physical infrastructure to be able to get that value out and to be able to use it. So let's come back to how this works. You take any SQL-capable client, and it could be dbeaver or a command line tool or Python or whatever it is. It's going to talk to your coordinator. And your coordinator is then going to distribute that query out to all the workers. The workers, which parallelize out, then use a number of connectors, and we have a whole page with a whole set of them, Hive, Delta, and so on. And they'll distribute that query out to the data sources, bring the information back up, aggregate it, send it to the coordinator, and give you the result. Few things to note here. One is that we've got a bunch of connectors, right? There's a whole lot of them, and we can aggregate this information. We can federate across them, so you can do a join across 2 different databases that are physically separated. And number 2, you see these lines for Hive and Delta Lake. When the data source supports it, which not all of them do, we'll parallelize on them so that we can pull the data in faster. So how does this look like specifically with Delta? So if we drill in on this lower left-hand corner, we can see a little bit better what this looks like when you're actually going to deploy this. And this is much closer now to what Tom is going to show you. So you pick object storage, and we don't really care what it is. This isn't even the full list. Most people in practice we see on S3 because it's just very common, but we see a lot of people on ADLS and GCS and so on. The right side, these self-managed, we tend to see more in finance and banking people where they're just like, we can't be on the cloud for whatever reason. On top of that, not falling off, you have a SQL compute engine. So this can obviously be Spark with Delta Lake, duh, right? You've all seen this. Or it can be something like Trino or Starburst, and they work together, right? As one of the use cases that they were trying to hit when they built Delta Lake was that you can have multiple things writing to the same processes writing to the same Delta table without them destroying everything. And so we can do that across, it doesn't have to be processes from the same engine, they can be different engines. So let's move on now. Who actually uses this? EMIS is one of the largest healthcare data providers in the UK. They cover 10,000 clinic groups, 120 million patient records, both current and historical. And their use of this is initially around privacy and security. As you can imagine, this is all very sensitive data. It's people's health status. And so they need to be able to segregate this out so when a clinic group gets access to this large data set that they hold, they only get access to the data relevant to their patients. There's another project which is actually even more interesting. Clinical researchers need to target their patients very carefully, right? This is very important for two reasons. One, for safety. You absolutely need to make sure that the people you're testing aren't going to get killed in your trial or suffer injury. And number two, these studies are all very expensive. And so if you can pick the right group, you can get better results and you can be more sure of what you're actually testing. But the researchers are not the patients, and they don't get to see their data until the patients sign up for the trial and voluntarily give it to them. And they're able to separate the data, give it to the people that need it, and make changes to these patient records as they come in, because of course Delta now lets you do that, right? You can do single row inserts, single row deletes, and updates, and so on. The other one we'll talk about today is Comcast. I'm sure many of you have had some interaction with Comcast. They work with Databricks as well. And they obviously have a ton of data. They maintain data on what is being shown in any given location. So in San Francisco and in New York, they're going to show different things. They maintain records on what the individual is doing, right? So who are you, where do you live, how many people in your house, and so on. And then what is actually being watched by these people. And these are all in a variety of different databases that for historical reasons, often in big companies, different parts of the organization, as they develop their new projects, will just use some database and then they're kind of stuck with it. Sometimes they do acquisitions. The acquisition has some data source with it, and you've got to work with it. And they are able to federate with this, with Trino, and use the resulting data to update a better viewing experience for the people who want to see it. And then, of course, for advertising, they can more effectively target those as well. So, where are we going from here? We open sourced the Delta Lake connector early in March, was it, I think? And that's been very well received. Since then, the bulk of the work has actually been on testing. It's not that it didn't work before. We had it in Starburst, and we were using it with enterprise customers. But testing is probably one of the most important things that our developers do. Because this is a project that we expect to keep going and to keep growing, we absolutely had to have a very rich set of automated tests that were not just in our enterprise product, but in the community, where when anyone contributes to our Delta Lake connector, and when we're working with the Databricks team on their standalone reader so that we can incorporate that eventually as well, all that needs to be tested so that when people actually deploy it, it works the way we need to. And then we work with them on these smaller incremental pieces that may not be obvious, right? So I'll give you an example, the second one here. You can mark a Delta Lake table to be append only, so nobody can delete anything and nobody can update any rows. With separation of storage and compute, the compute engine needs to know about that and it needs to honor that, so we've been able to add that. Coming up are two major features that we're going to be wrapping up this year. Number one is time travel. So does everyone here know what time travel is? Some people, yeah, there are great movies, several great movies about it. Delta Lake lets you, because of how Delta Lake stores changes to the table, you can actually go back and say, what was the state of the table at some arbitrary point in the time, in the past? So the obvious use case is, oh my God, at midnight last night, somebody destroyed my table. Let me roll back to 11:59 and I'm good to go. That's the obvious one. We've heard some people say, no, we actually need this for auditing. Every once in a while, our regulator comes to us and says, hey, we need your records from January 15th of 2019. You've got 30 days to go with. Chop, chop, get it for us, right? As of syntax is a much easier way to get that than going back to old tape archives. The third one that we've heard is when your model looks a little funny and you're like, I don't know, something's wrong with this, but it was run yesterday. And since then, all your data's changed and you're not really sure where the source of the problem is. So people are saying, well, it would be really cool if I could just roll back to when the problem occurred, have exactly that data set. I'll CTAS that into some other table. Now I can work on it, now I can debug it, and I'll be ready to go as soon as I'm done. The second one is Materialized Views. Now, everyone is probably familiar with Materialized Views as a single database concept, right? You do a view, and then you stick it in a table, and it sits there. And it has the advantage that it adds some syntax. When you refresh a view, it remembers how you created it. So it's not just a simple CTAS. With Trino, we can federate that. So the information from the view doesn't have to come from the data source that you eventually put it. We have all these connectors, so somebody may say, well, I really want to do some big ML project, right? I need a data set and I need clean data sets, and I don't want to deal with the data engineering part of it. You can use Materialized Views to join your data from Teradata and SQL Server and Google Cloud and whatever, put them into Delta Lake, have that run as a refresh. We can actually do incremental refreshes so that when there's a change in one of the source tables, we don't have to kill everything and redo your 1 terabyte materialized view. We can just add the new pieces on, and then any other process can use them. We've seen this. We have a banking customer who is using materialized views to power a dashboard, which took the query times down from 10 minutes to a minute and a half. And there was a lot of data. They couldn't get it down below that just because of the sheer amount that was going in, but they were pretty pleased with that. So we've gone over what Trino is, how it works with Delta Lake, how that can get you a Lakehouse on completely open hardware, completely open software, and how people use this in the real world. Before I hand this off to Tom, let me see if there's any questions here before we go on, and we can have more questions at the end. Yes, please. There is a MongoDB connector. Do we? I don't know if we have DocumentDB off the top of my head.
No.
No.
I think that's being worked on right now.
Yeah. We have a lot, and we're starting to go through and more carefully catalog all the connectors so you know exactly what's supported in the various ones, because usually what we'll do is we'll build reads in first, and then we get the performance up to, there's usually some work on that, and then we'll start adding writes. Once we have the basic CRUD operations in, then we start adding in the bells and whistles of a particular data source. Yes?
Do you know what's the difference between like running Trino, Hive, and S3 versus this setup? The performance difference, read performance difference.
Trino Hive on S3 versus Trino Delta on S3?
Yes.
Okay, right now our Hive connector has a slight performance advantage just because it's older and we've had more time. In general, aside from the capabilities of the engine, Hive and Delta do have very similar performance in sort of raw read-write. But because Delta lets you work with your data differently, you can often structure your workflow so you're doing fewer write operations. A very simple example. If you're inserting a single row, well, in Delta, you can just insert the row. In Hive, you've got to redo the whole partition, right? And that's just going to take longer. So does that answer your question?
Yeah, and
Cool.
I think recently, just within the last couple of months, we've done a lot of benchmarking, and Delta's way faster now. And it's mostly because the S3 reads. So you have doing an S3 listing on everything. You don't have to do that with Delta. So that's the biggest thing, is when you have a whole bunch of files, 10, 20, 100,000 files, we're seeing huge performance reads. So that's why and I'll show you a little demo of it, just the reading part of things is always going to speed up. And then you add partition pruning into it as well. you get a huge speed up. So
Yeah, absolutely.
Should I hold the architecture question? Want to see where does the Trino run?
What do you mean, where does it run?
Like, where does the engine run for Trino? Like, how does it, like, it should be installed on a separate set of machines, or?
Oh, yeah. Let's talk about that later. I think that's sort of an implementation detail. We have a number of ways to deploy it. Tom's going to show it to you on Galaxy, but you have a lot of options there. One last point, I'm going to hand this to Tom here. A lot of the speed improvements on Delta, and for the set of connectors where we separate storage and compute, so Delta and Hive and things like that, come down to table stats. Because once you've separated these things, the engine really needs to know what's going on in the table so it can intelligently create these query plans, know what piece to send from where, know which files to pick up so it's not getting a lot of redundant information. So as we've been adding that, performance has really gotten significantly better. So, all right, thank you. Let me hand it over to Tom.
all right,
And we'll have time for a few more questions at the end.
all right, sounds good. Let's see here. I'm using a product that we have called Galaxy, which is basically hosted Trino. So we're going to play like I'm sitting on Trino. It's just easier for me to deploy. What I'm going to go through here is, there's actually one more slide, isn't there? There we go. Let me go through this real quick. In this example, this is typically what we see from a lot of our customers. We have data that's coming in from whatever different data sources we have. Let's say a database that has customer information in, and then some kind of sales data source that's just populated JSON files. So in this example, I have landed raw data files that are coming in through JSON. And I kind of switch this up at the last second because I kind of want to show you some federation. So actually my customer information is going to come from a Postgres database. And then the sales data is going to be landed on S3 just with JSON files. I'm going to take that and convert that over to Delta. And then from there, I'm going to do roll-up tables. So sales by week, month, and year. And then obviously all on AWS using Glue. And then I'm just going to show you through a query editor. Again, you can connect to this through a BI tool. So let me show you what that looks like from the S3 point of view. So on S3, let me go back here. Here we go. So S3, I have this data being landed, and it's a directory per day. So I have these JSON files that are landing, and this is obviously a small demo. You'd have a lot more information, but we all know that JSON's not very performant. So from here, I'm going to create. Let me go to my query editor. The first thing I'm going to do is I'm going to create an external table that points to this data that sits out on sales land. So let me go ahead and execute that. And since that's just an external table, there's not much going on there. And usually I would just run this call system because I need to go tell Glue that there's a whole bunch of directories out there with our partitions. So I wouldn't cheat it. I have a table called W. So I've already done that. So if I just say select star from that. So this is the JSON files that I'm reading out there. It's all partitioned by day. So there's like 2,000 or something like that. There's a whole bunch out there in this sample data set. So the next thing I'm going to do is I'm going to create a Delta table from that table. So I'm going to say create table first. Type is Delta, and I'm partitioned by order date as well. So I'm going to go ahead and run that. I'm not doing anything with data, so I'm literally just creating a table that's sitting out on S3. So if I come out here and go back to S3, I should have this sales base. So there's nothing there yet because I haven't populated it yet. So I'm going to go ahead and make this a little bit faster with my min partition. And I'm going to insert into demo sales base, that's my base, and I'm going to select star from my landing table. So this is just a 2-node cluster. This takes about 8 or 9 seconds to populate. So once this goes in, I'll show you what it looks like in S3. So I get 97%, and that's it. So about 754,000 rows. So if I come into sales base, this is basically the same thing that you just saw, but now I have this Delta log table. So this is a Delta table. So I have the initial JSON file in there when I created the table, and then I have that last insert I did with all that data that's sitting out there. So the next thing I'm going to do here is come down here. I'm going to say just select star just to show you that I can query that table. And this is what I would, if my end users want to go directly to the data, I would direct them to this. I wouldn't have them query the JSON because it's just too slow. This is all in Parquet and in Delta, so it's going to be much quicker for them. So then here's my customer information. I have it in a Postgres database. So I can just go ahead and just connect and just say select star from that Postgres database. And this is my customer information. So I have 2 different options here that I can give my end users based upon what my SLAs are. So I can join that S3 data, that sales, that Delta Lake table with Postgres. So if I just join these 2 tables together, This is going to give me the real-time information from Postgres, but it may not want to do that because I don't want maybe all the users joining a lot of data with Postgres because that's the live, let's say it's a CRM system. So what I want to do is I want to create a Delta table from that customer table. So I'll create customer base, the type is Delta, just select star from that. And I could create some another job in here that only gets change customer information, new customer if I wanted to. So now I have both tables that are sitting out on S3. If I say select star, now if I go back to here, I have now my customer base table, which is now Delta. So I have two tables out there that are both Delta, and then I'm going to create some roll-ups. So I'm going to create a roll-up here that is type of Delta. It's going to be ordered by, the date format is going to be by week. So this is going to be a weekly roll-up. I'm going to go ahead and run that. And these are all Delta tables. Because I want to make sure that I have like we did that question we talked about before. I want the most performance, the highest performance I can. So I want to make these Delta. So I'm going to go ahead and run the monthly roll-up, and then this is a yearly roll-up. There's different ways you can do roll-ups. You can just basically drop them and then recreate them. You could use views. You could do incremental updates to roll-up tables, whatever you want to do. So I'm going to go ahead and select from my weekly reporting so you can see the day of the week, the last 7 days of my sales, and then I've got a monthly. This is going to cover a year of data of my sales, and then my yearly. So I think I just have 2020 data in here. So that's my sales for the entire year. So the next thing to do is what we did is when we created the Delta connector is we just looked at the spec. We worked with TD and Danny and the Databricks folks to make sure that we followed all the spec correctly. So we added update in here as well. So we have full DML support. So I'm going to say select star, and I'm going to grab this customer, call customer, blah, blah, blah. I'm going to update that customer to John Dodds. And if I go look out in here, and I'm going to go look in my customer base, I've got two JSONs in here. So one was my first initial insert, and now I have an update statement in here. So let me go back and say select, and now that customer is going to be John Dodds. So just to point out that we have full DML, delete, insert, update as well. I know we're going to be adding merge pretty soon as well. So merge and time travel, I think we miss out on the roadmap as well. And then all the other utilities that everybody kind of knows from Delta Lake. So I'm going to do an optimize here. And this is going to be against the sales base table. So we'll go ahead and optimize that. And this is the same thing that you would do in open source Delta Lake or Databricks as well. I want to make sure those small files combine those into larger files as well. And then we also have a vacuum that I'll show you in just a second here. So if I go to, we'll give this a second to finish. There we go. So that took about 17 seconds. Next thing I want to do is just do a vacuum. So I'm going to come in to go to my sales.
Does everyone know what vacuum does? And okay, great.
Good. And then my sales base. So if I come into my sales base, I'm going to go pick on one of these guys. Since I did that optimize, I have two files in here. So I'm going to go ahead and run this vacuum command. I'm going to put it at 0 seconds. We follow basically the same spec that Databricks did with Delta Lake. So it's very, very similar for if you've used something like Databricks or something like that, or open source to call this. So this is going to go through and just vacuum all those old files up there. Let's see if that caught up yet. There it goes. Now it's gone. So that's finished that. And then the last thing I want to do is have something that we added, because our engine's a little bit different, especially when it comes to SQL. We need extra statistics. One of them is like NDVs, which is a number of distinct values. So if I'm going to analyze the sales base table, so let me go back to sales base. And then under Delta log, I just have my checkpoint files that I have now. So if I run this analyze command, this is going to go through and basically count all the number of distinct values that are in that table. And we create an additional directory called Trino metadata. So we need this extra stats in here. We could do without it, but we find out when we have, especially when we're doing joins against tables and stuff, our performance greatly increases when we have these extra statistics that we need for our engine, for our cost-based optimizer. So that's about it. We have optimized vacuum, went through all the DML information. So this is kind of what we're seeing a lot of our customers using Delta for, is they're either writing the files, either Delta, and then getting us involved with high concurrency, especially with BI tools, thousands of users querying the data at the same time, and then also creating the Delta files as well using Trino. And I think that's it. So I'm going to go back to slideshow here. And then I want to finish it off and ask if there's any questions or anything.
Yeah, so thank you, Tom. So what Tom just showed, which fortunately matched everything I said, yay, is that you can use Trino and Delta Lake to have your fully functional Lakehouse. It works, it uses off-the-shelf components, and it's a very simple way to enhance any Delta Lake, whether you already have Databricks on it, or as in the case of EMIS, they had initially only used, they had added Databricks later once they started needing more AI and ML capabilities on their data. But whether or not you have this, it makes sense to put Trino on so that if you have high concurrency workloads that you need, federation use cases, if you have parallelization that you need, or moving data between data sources. So let's take a little bit more time. I think we've got 8.5 minutes. Hey, what's your name?
My name's Jay.
Hi.
Quick question. You see the product evolution in Databricks, like moving towards more SQL, serverless, and stuff like that. I mean, what is the roadmap for Trino? I mean, it's kind of conflicting, right? For SQL front end being, if you're a Databricks customer, why would you use Trino?
Sorry,
I can answer that.
didn't
Yeah,
know
he's
the
trying to figure out what the overlap is, right? That's a great
Oh,
question.
okay,
There's
yeah,
overlap,
yeah.
yeah.
So I mean, the way I look at it is there's two big plays that for Trino, right? Is the federation. So there's over 40 connectors now. So we see that in really large enterprises, especially they have legacy source systems that are around. They want to do exactly what I just showed you. They have data, but they don't want to pull that constantly into S3. They want that data right now. So that's a huge use case for us is high concurrency federation story. And then basically data lake. I mean, there is overlap, right? Let's all be serious here, right? It's one thing they built. We replaced Hive at Facebook. That's what Presto did. That's why it was created in the first place. And we still continue to do that. I still think we're one of the fastest, the high concurrency SQL query engine on a data lake. That's going to be, obviously there's Photon, right? So we'll see how that works out. But I think what we've really invested in the last 2 years that I've seen is really the federation story. Sure, we had connectors, but actually look in the statistics and figure out what do we want to push down to the source system, and then have that database do the join, only pull the data back that I need, and then join that with whatever, S3 or something like that. That's when I've seen the biggest amount of engineering that Claudius is a part of in the last 1.5 years. You want to add to that?
Yeah, so okay, thank you. I misunderstood the question. So one of the things that if you were, when they were talking about the SQL support they were adding, the federation support, they started talking about the query planner. So when we built all these connectors initially, to some extent, when we were federating, we had to take a very naive approach, right? So if you want to join across 2 data sources, what's the simple way to do it, right? Pull in everything from one and the everything from the other, bring it into your engine, figure out what joins, and throw out the rest, which is terrible, right? It's just no good at all. And I'm sure they don't do that, right? Like the worst of it is kind of easy, low-hanging fruit to pick off. But what we have spent, I don't know, like 10 years now or so doing is being much smarter about how we do that federation. Dynamic filtering, which Tom had mentioned, is one piece which will look at the query plans beforehand, look at the NDVs, look at the stats that we collect, and say, okay, we know from this table, this is all, these few rows are all we're gonna need, and we only need these 2 partitions from here. Let's just get that. If we can say, to some data sources, you can push down a predicate, right? So you can say, okay, give me the rows that match these criteria, and then you really minimize what comes back in. Sometimes the individual data sources, when they have an engine built in, those engines are very good at doing things within that data source, and we let them do that and then take care of the pieces that they can't do on their own because they're limited to a single data source. Does that help?
Yeah, thank you.
Cool. Yeah, push down is a whole major initiative. So I also work with our performance team very closely. And push down is just a major thing. We can push down all kinds of different pieces, but you're absolutely right. There are limits to what you can push down. There are some things you just can't, right? I'll give you an example. One of the awesome things that we got with with data lakes. Let's give data lakes, not Lakehouse, data lakes credit where it's due. They separated storage and compute so we can scale them individually. But the storage layer is a giant glorified hard drive, right? It's just a big distributed hard drive, and it's dumb. It's like just a bunch of files. And so you cannot tell that giant dumb hard drive, give me the third row in this file. It has no idea. You have to pull up the whole file, and that's going to be your limit there. So we are going to run into some of these limitations. We're just going to keep pushing to get as close to that as we possibly can.
And then you're also going to see in a lot of the databases I worked at Teradata and worked on Teradata a lot of times, a lot of years, and a lot of times sometimes it actually, with a filter, to be able to pull that data out of Teradata, and then we're an MPP engine. We want to do joins and aggregations in our engine because we're going to be a lot faster most of the times, right? There's a lot of times when you're joining Teradata, everybody fights for the temp space, right? So there's a lot of times where, like Comcast is a great example, where we want to treat Teradata as storage. We want to treat some of these data sources as storage because we can actually pull that data out, do all the dynamic filter, all the really cool things that we can do. We can do that much quicker than a overworked database can. So that's a lot of the work that's been done in the last 2 years is getting down to that. Instead of pulling everything out of the tables, let's just get intelligent about it. And that's why statistics are so important to us. And that's why we had to add that analyze command, because to really get that proper joins and the performance, we need extra statistics. I can't say that word. Out of Delta Lake, but we need that for all of the storage. We need as much information, just like a typical database, right? The more information we get, the better joins and performance we're going to give you.
So in 2.5 minutes, the giant hook is going to pull us off stage. So we've got one here, and I think I saw one there. I think we do too. Right?
How scalable this setup is, because we are running Trino on Hive and S3, and we are having troubles with 250 nodes, 250 worker nodes. So in terms of nodes and amount of data it can process, how scalable the setup?
Yeah, I mean, we've had much higher scale than that. It can be challenging. So let's talk afterwards. We can try to figure out what the situation is with you, and we can maybe get you connected with some of our engineers to figure out what the issues, the specific issues. How does Trino handle
the access and permission? Because I guess there has to be some sort of IAM role or instance profile attached to the compute to access the S3.
Yeah.
But does that mean everything going to have exactly the same? Everyone going to have exactly the same permission when running the query?
So is the question, how do we access a private S3 bucket?
No, like the question is more like, let's say we have 2 Delta tables, and we potentially want to have separate permission for these tables when we provide this query service to different users. Like, how do we handle different permission inside our Trino?
Gotcha. Yeah, so like there's something called file-based access control in Trino in open source that you can control that based upon like an IAM role. So there's IAM role mappings. So you can have certain IAM roles that you can only access certain tables. So that's just been added within the last year. So if you go to trino.io and go to the security part, there's a couple different ways to do authentication that way, and then control. So we could talk afterwards as well. I could show you where it's at.
Yeah, that's all the time we have for questions now.
Denied.
Please reach out to Tom and Claudius after the session.
All right. Thanks, everyone.
We'll be back there and happy to answer any more questions. Thank you.